Industrialization has brought many benefits to our planet. Even in the remotest corners, mechanization is introducing change. New wells deliver plentiful fresh water. Low-cost machines improve productivity and help farmers increase yields. And mains electricity is providing opportunities that once were only available to the very rich. For an increasing number of people, technology is creating a better world. But there is a cost. Man-made atmospheric emissions damage the Earth. The widespread use of fossil fuels, charcoal, firewood, coal and petroleum products comes at a price. Cities and even whole continents are slowly choking in a cloud of photochemical smog. Acid rain is eating away at buildings and contaminating groundwater supplies. Ozone depletion in the upper atmosphere threatens to unleash an epidemic of skin cancer among both old and young. And an increased concentration of ozone at ground level can aggravate asthma and other respiratory diseases. The message is quite clear. We cannot continue to pollute. In this video, we will look at atmospheric pollution and its causes. You will learn about the impact shipping has upon the environment, and gain an understanding of MARPOL Annex 6 and how its implementation will affect the day-to-day operation of your vessel. There are a number of damaging classes of atmospheric pollutants. Oxides of nitrogen, NOx. Oxides of sulfur, SOx. Volatile organic compounds, VOCs. Refrigerants and firefighting agents like freons and halons. And other toxic gases arising from shipboard incineration and combustion of contaminated fuel. Oxides of nitrogen and oxides of sulfur arise as a byproduct of fuel combustion. In the marine context, the release of volatile organic compounds mainly results from the transporting and the loading and unloading of petroleum products. To understand why they damage the environment, we must look at the chemistry of atmospheric pollution. In the presence of sunlight, nitrogen dioxide, together with nitric oxide, react with volatile organic compounds such as vaporized hydrocarbons to produce ground-level ozone or photochemical smog. This is not the only reaction that may take place. For instance, oxides of nitrogen and oxides of sulfur will combine with hydrogen and oxygen to form nitric and sulfuric acid, both of which contribute to acid rain. The discharge to the atmosphere of freons and halons results in the destruction of the upper ozone layer. An influential 1997 study by Corbett and Fishbeck showed that ships were an important source of atmospheric emissions. Globally, they contribute some 14% of oxides of nitrogen and 16% of oxides of sulfur. In certain areas, the concentration of ship-generated atmospheric pollution can be even greater. California attributes 30% of airborne oxides of sulfur to shipping. The impact of the marine industry on air quality is significant. There are the exhaust emissions from engines and other machinery, poorly combusted materials from onboard incineration, the release of volatile organic compounds during the transportation and the loading and unloading of petroleum products, and the accidental or deliberate venting of freons and halons, either from the ship's refrigeration systems or from firefighting installations. Given the size of the problem, many countries have resolved to impose restrictions. To this end, from the 19th of May 2005, the signatory nations of the MARPOL Convention will introduce Annex 6 into law to limit air pollution from seagoing vessels. Its impact will be wide-ranging and will affect many shipboard operations. Except where specifically exempted, MARPOL 7378 Annex 6 will apply to all vessels, however large or small. It will apply to fixed and floating drilling rigs and other platforms. And certification is mandatory for all qualifying ships that trade internationally. It introduces strict limits on emissions of oxides of nitrogen and oxides of sulfur into the atmosphere. Every qualifying marine diesel engine must be certified to meet the new oxides of nitrogen standards over its entire service life. The certification procedures and methods are defined in the Oxides of Nitrogen, NOx, technical code. Furthermore, it specifies how compliance can be demonstrated in service. To limit oxides of sulfur, SOx, the sulfur content of bunker fuel is to be capped. Additionally, SOx emission control areas, seekers, are to be introduced. Here, more stringent limits will apply. There will be tighter controls on shipboard incinerators. And it will standardize the type of tanker vapor emission recovery system where their use is mandated. The Annex specifically sets out the disposal procedures for gases used in refrigeration and firefighting systems. Annex 6 will be policed by a system of survey and certification carried out by or on behalf of the ship's flag state. To meet MARPOL Annex 6, a vessel must hold an International Air Pollution IAPP certificate or equivalent. This certificate must be renewed at least every 5 years. Additional surveys are carried out at regular intervals to ensure the vessel's equipment is maintained and its operating procedures correctly implemented. Furthermore, there may be further inspections made by port states. Annex 6 also affects what modifications can be carried out. In particular, it imposes certain restrictions on how engine maintenance is undertaken. Annex 6 oxides of nitrogen, NOx controls, apply to diesel engines installed on all ships keel-laid on or after the 1st of January 2000. The engines on these ships should have been issued by or on behalf of the flag state, with an Engine International Air Pollution EIAPP certificate at the engine builder's works. In detail, Annex 6 NOx controls apply to every marine diesel engine with an output over 130 kilowatts. It excludes engines solely used for emergency purposes. But where an engine has a dual use, then the regulations apply. Engines on vessels keel-laid prior to the 1st of January 2000 are generally exempt, except where such engines have been subject to major conversion, as defined by the Annex after that date. This can include installing a replacement new engine, increasing the power output by 10% or more, or changing engine rating, components or settings that adversely affect oxides of nitrogen emissions. This means you do not have the freedom to alter engine settings outside of the established range. Furthermore, replacing some parts on older engines with new or redesigned components could bring them into the scope of the regulations. It is the responsibility of the ship owner to prove such changes do not increase the emission of oxides of nitrogen. Complying with NOx emission levels is not straightforward. The level of oxides of nitrogen produced is largely dependent on the temperature in the combustion chamber. Air is 78% nitrogen by volume. At high temperature, some of this nitrogen, together with much of the fuel-bound nitrogen, combines with oxygen to form oxides of nitrogen, NOx, NOx. At temperatures in excess of 1600 degrees Celsius, the formation rate of NOx rises significantly. Lowering the temperature by, for instance, retarding the fuel injection timing will reduce NOx, but will tend to increase fuel consumption. At the engine builder's testbed, the parent engine's duty cycle weighted NOx emission values are determined at specific reference conditions. These include factors such as the fuel type, the inlet air temperature and humidity, together with the primary coolant temperature. The NOx emission limits for marine diesel engines are related to rated crankshaft speed. At 130 RPM or less, the maximum permitted relevant duty cycle NOx emission value is 17 grams per kilowatt-hour. Between 130 to 1999 RPM, the limit is calculated by multiplying the rated crankshaft speed raised to the power of minus 0.2 multiplied by 45. For example, for a 1000 RPM rated engine, the limit would be 11.3 grams per kilowatt-hour. At speeds equal to or greater than 2000 RPM, the limit is set at 9.8 grams per kilowatt-hour. All relevant oxides of nitrogen information for each engine must be included in the NOx technical file. Usually prepared by the engine builder, this document must be approved by or on behalf of the vessel's current flag state. At the very least, the NOx technical file must identify the engine type and model, its serial number, rated power and speed, together with the duty cycle for which it is approved. It must specify the allowable NOx critical component options and the permitted range of settings, such as fuel pump timing. Detail the onboard NOx verification procedure relevant to the particular engine. There must also be a copy of the emission test report used to certify the engine and the EIAPP certificate or equivalent. If applicable, there should also be a copy of the designations and restrictions for that particular engine group. For example, maximum charge or scavenge air temperature under reference conditions. The technical file must be original, maintained, on board, in good order. It must not contain unauthorized amendments. And it must be available for inspection at all Annex 6 surveys. Finally, for each engine, a record book of engine parameters maintained by the ship's staff records all changes to the engine, including parameter settings and replacement components that may influence NOx emission levels. Oxides of sulfur, SOx emissions, are to be controlled by introducing a 4.5% cap on sulfur content of all marine fuel oils, irrespective of their use. From the 19th of May 2006, in certain designated areas known as SECAs, SOx emission control areas, this will be further reduced to 1.5%. The first of these SECAs is the Baltic. The North Sea and the English Channel are expected to be designated as a seeker in the near future. Meeting the 4.5% fuel oil sulfur limit is unlikely to be a problem. Complying with the lower limit is more problematic. For vessels that do not enter, or for those who only operate in a seeker, it is only a case of loading the fuel oils with the correct sulfur content. However, vessels that move between restricted and unrestricted areas face a stark choice. Either burn low-sulfur bunkers all the time at a higher cost, or install segregated bunker capacity and switch between high and low sulfur fuels. Even then, it is vital to fully complete the changeover of fuel type before entering a seeker. Otherwise, a ship will be in breach of Annex 6. Switching between high and low sulfur bunkers may have an impact upon fuel stability and engine lubrication requirements. In some cases, a vessel may need duplicate fuel service tank systems and 2 grades of cylinder lubricant. The introduction of seekers will also have an impact upon operational procedures. The ship's log must record the date, time and position when changeover of fuel is to be completed prior to entry and on commencing changeover after exit. It should also record the quantities of low-sulfur fuel in each tank, storage, settling and service when going into and leaving a seeker. These amounts must tally with the take-up of bunkers entered into the oil record book. Ensuring the correct bunker grades have been loaded is the responsibility of the ship's master. Bunkers should only be ordered from suppliers who are registered with the relevant authorities in the country where they operate. A bunker delivery note is required for each delivery. This must contain, at the very minimum, the name and IMO number of the receiving ship, the date of supply, the port, the quantity, the density at 15 degrees Celsius, the sulfur content, and the name and address of the supplier. There must also be a signed declaration by the supplier's representative that the fuel oil is in conformity with the stipulated Annex 6 regulation. The receipts must be kept on board for a minimum of 3 years from the date of supply and be available for inspection. Additionally, for all fuels, the bunker supplier must provide a sealed representative sample taken in accordance with IMO guidelines. This sample is retained under the ship's control, with its seal unbroken until the fuel is substantially consumed, but for no less than a year. This sample is specifically required by Annex 6. It is not to be confused with the commercial sample or that used for fuel testing purposes, and must never be used in place of those samples. Incineration will be subject to further restrictions. Incinerators installed on or after the 1st of January 2000 must be type approved to the required IMO specification, and there must be an operational manual on board. For all incinerators, the operators must receive appropriate training in their correct use. The incineration of polychlorinated biphenyls, PCBs, are now explicitly banned, as is waste containing traces of heavy metals, refined petroleum products containing halogen compounds, and residues of cargo oil. The discharge of volatile organic compounds through the loading and unloading of petroleum products has been largely ignored even though it can be effectively controlled. To reduce the release of volatile organic compounds, the regulations allow countries to enforce the fitting of specified type-approved vapor emission control systems to tankers operating in ports and terminals within their jurisdiction. A list of all such regulated ports is maintained by IMO and circulated to all interested parties. Annex 6 prohibits deliberate venting of ozone-depleting substances. These include freons and halons. New installations containing these substances are prohibited, but systems using hydrochlorofluorocarbons are permitted to be installed until the 1st of January 2020. When servicing, renewing, or decommissioning firefighting equipment or refrigeration units containing ozone-depleting substances, there must be no emission of those gases to the atmosphere. Any contravention is, ultimately, the responsibility of the ship owner, and it is their task to choose a responsible partner for carrying out such work. Member states must provide onshore reception facilities for the disposal of freons and halons. And if there are inadequate facilities, the master should report them to their flag state. MARPOL Annex 6 is a sensible and timely measure designed to cut atmospheric pollution, particularly acid rain. It will reduce the depletion of the upper ozone layer and alleviate respiratory illnesses aggravated by oxides of nitrogen. Its ratification and implementation will have a substantial impact on air pollution and help the marine industry maintain its green credentials. Most importantly, it will mean that we will all live on a cleaner and healthier planet.